Uh, in this lecture of S2 BCom CA and Corporation for Business Mathematics, we are looking onto the topic adjoint of a matrix. Adjoint of a matrix. So adjoint of a matrix is represented in the form Adj of A. So this is how we represent adjoint of a matrix, and this is calculated by in order to find adjoint of a matrix, first step is to find the cofactors. So you need to find the cofactors. So once you find the cofactors, you need to transpose these cofactors. Transpose the cofactors. Okay. So adjoint of a square matrix can be defined as the transpose of a matrix of cofactors. Transpose of the matrix of cofactors, and it is denoted by Adj of A. For example, if you have a matrix A, so it's a general format, so we'll write A11, A12, A13 up to A1n. Then in the second row we have A21, A22, A23 up to A2n. And if we are having m rows, we'll write AM1, AM2, AM3 till AM of n. So this is our matrix. So we will find the cofactors. So we rewrite the cofactors as A11, A12, A13 up to A1n. And if we have a second row, A21, A22, A23 and A2n. Likewise, it goes up to m rows. So AM1, AM2, AM3 up to AMN. So this is adjoint of A. Okay, so if A is a matrix of mn rows, then adjoint of A is the cofactor transpose. The transpose of the matrix of cofactors. Transpose of matrix of cofactors are known as adjoint of a matrix. Let's see adjoint of a matrix of order 2. So let's consider a matrix A, which is of 1, 4, 2 and 7. So you are asked to find adjoint of a matrix. Adjoint of a matrix A. So what is the first thing you have to do is you need to interchange this value and this value. So interchanging, you get the answer so I'll write adjoint of A. One second. Adjoint Adj of A is equal to, you interchange the position of 1 and 7. So 1 will be occupied with 7 and 7 will be occupied by 1. Since these are positive numbers, we switch the sign of these numbers. We don't have to interchange, only switch the sign. Since it is a positive number, we give a negative number, that is -4, and this a -2. So this is the adjoint matrix of a 2 by 2 matrix. Another example, if A is equal to 1, -3, 5 and 4. If this is the matrix, you are asked to find the adjoint of A. So adjoint of A will be equal to, you interchange 1 with 4 and 4 with 1. Since this is negative number, it will change to a positive and this will be a negative number. So this is how we do the adjoint of a 2 by 2 matrix. Now let's find what is the adjoint of a 3 by 3 matrix. Adjoint of a 3 by 3 matrix. Okay, so let's find the adjoint of a 3 by 3 matrix. So let A is equal to 7, 6, 2, -1, 2, 4, 3, 3 and 8. So we are asked to find the adjoint of this matrix. So first position is A 1 1. So the general formula is -1 raised to 1 plus 1, that is 2. Into, you cover this particular row and column, you will get it as 2 into 8, that is 16, minus 3 into 4, that is 12. So it will be 4. Now A 1 2 is equal to -1 raised to 1 plus 2, that is 3. Okay, you cover the particular row containing 1 2, so 6 2 3 and 7 6 2 is covered, so it will be -8 -12, so it will be -20. So minus of -20 will be equal to +20. Okay, now A 1 3 is equal to -1 raised to 4 A 1 3. So you cover this particular element containing the column and the row, you will get it as -3 -6. So it is -9. Now A 2 1 is equal to, you cover this particular column and the row, you will get it as -1 raised to 3 into -1 raised to 2, that is 7 into 8 is 56 minus this column and this row. 6 into 8 minus 6, it is 6 into 8. So if you have it out, you will just do this like this way and this way. So it will be 6 into 8, that is 48 minus 6. So we'll get to the answer 42 minus 42. Now A 2 2 is equal to -1 raised to 4. -1 raised to 4, you cover the row and the column. So this column and this row, so it will be 7 into 8, that is 56 minus 6. So it will be 50. Now A 2 3 is equal to -1 raised to 5, and 2 3 you cover this column and this particular row, it will be 21 minus 18. So it is minus 3. Now A 3 1 is equal to -1 raised to 4. So you cover this particular column and the row. I'll take another color. So this particular column and this row. So we'll get the answer as 6 into 4, 24 minus 4, we'll get it as 20. Then A 3 2 is equal to -1 raised to 5. So you cover this column and the row. It is 28 minus of -2, that is +2. You'll get it at 30 minus 30. Then A 3 3 is equal to -1 raised to 3 plus 3, that is 6. So you cover this particular column and the row, you'll get it as 14 minus of minus 6, that is 20, positive 20. So these are the cofactor. We found all the cofactor. Now we write all the cofactor in the form of 4, 20, minus 9. Then we have minus 42. We have 50, minus 3. Then 20, minus 30, 20. So these are the cofactors. Then transpose of the cofactor. So we need to find the transpose of this. So adjoint of A is equal to 4, 20, minus 9, minus 42, 50, minus 3, 20, minus 30, 20. So this is the adjoint of the matrix. So this is how we find the adjoint of a 3 by 3 matrix. So first you need to find the cofactor, then you're asked to find. So first you need to find the cofactor, then you need to find the transpose of the matrix. Now let's see the inverse of a matrix. Inverse of a matrix. Inverse of a matrix. So a matrix B is said to be a matrix B is said to be the inverse of A, if A into B is equal to I, should be same as B into I, where I means it is an identity matrix, where I is an identity matrix. Okay, so A matrix B is said to be inverse of A if this satisfies. The equation is A into B is equal to I. That should be also equal to B into A. So there is a property regarding this. So property is that when you multiply A and adjoint of A, that is always equal to determinant of A into identity matrix. Determinant A into identity matrix. Determinant of A into identity matrix. If that is that, and then how do you find the identity matrix? Identity matrix will be equal to A into adjoint of A by determinant of A. So I will be equal to A into adjoint of A by determinant of A. Okay. Then if I say B is the inverse, if I say B is the inverse of A. If I say B is the inverse of A, then I represent A inverse is equal to B. When I say A inverse means is equal to B. That is adjoint of A by determinant of A. Adjoint of A by determinant of A. So A inverse is calculated by initially finding the adjoint of A and dividing with the determinant of that particular A. So this is the equation. So general equation for finding an A inverse is equal to, initially you need to find the adjoint of A divided by determinant of A. This is the equation for inverse. So let's see how to tackle this question. So let's consider a matrix A is equal to 1, 2, 2, 2, 1, 2. Then we have 2, 2, 1. So this is a matrix. So we need to find A inverse. So initially we'll be finding determinant of A. So determinant of A is 1 into 1 minus 4 minus 2 into 2 minus 4 plus 2 into 4 minus 2. So that is equal to minus 3 minus 2 into minus 2 plus 2 into 2. That will give you an answer minus 3 plus 4 plus 4. That is 8 minus 3. 8 minus 3 is equal to 5. So determinant of A is 5. So determinant of A is equal to 5. Now let's find what is adjoint of A. Let's see what is adjoint of A. So adjoint of A is calculated with the cofactor. So in order to find adjoint, we need to find all the cofactors. So A11 is equal to minus 1 raised to cube. Minus 1 raised to 2. Then 1 minus 4. That is equal to minus 3. Okay. A12 is equal to minus 1 raised to 1 plus 2, that is 3. Then you cover this particular column and the row, you will get it as 2 minus 4, that is minus 2. Minus of minus 2. Minus of minus 2. That will give you an answer 2. Then A13 is equal to minus 1 raised to 1 plus 3, that is 4. So you cover this particular column and the row, it will be 4 minus 2. So it is 2. A21 is equal to minus 1 raised to cube. Then you have to cover this particular column and this particular row. So you will get the answer as 2 minus 4. That is minus of minus 2. You get the answer 2 again. Now A22 is equal to minus 1 raised to 4. Then you cover this particular column and the row. So it will be 1 minus 4. 1 minus 4, you get it as minus 3. Now A23 is equal to minus 1 raised to 5. Minus 1 raised to 5. Then you cover this particular column. The row is already covered. So this particular column you cover. Then it is 2 minus 4. That is minus 2. So minus of minus 2. That is 2. Now A31 is equal to minus 1 raised to 4. You cover this particular column and the row. So you get the answer as 4 minus 2. You get 2. Then A32 is equal to minus 1 raised to 5. Then you cover this particular column and the row, you will get it as 2 minus 4, that is minus of minus 2. Then A33 is equal to minus 1 raised to 6. Then you cover this column and the row, it is 1 minus 4, that is minus 3. Now write every element in the square bracket. So it is minus 3, 2, 2, 2, minus 3, 2, 2, plus 2, then you write minus 3. So this is the cofactor. So you need to find the transpose of the cofactor. So the answer will be, you change all the row to a column. So it is minus 3, 2, 2, 2, minus 3, 2, 2, 2 minus 3. So this is the adjoint of that particular matrix. If this is the adjoint of a matrix and the determinant is 5, then A inverse is equal to, you rewrite the particular matrix as 3 minus 3, 2, 2, 2 minus 3, 2, 2, 2 minus 3 into 1 by 5. This is how we find the inverse of a matrix. So first you need to find the adjoint of a matrix, then you divide with the determinant of A. So we'll do one more question. Consider the question. A is equal to 2 minus 1, 3, 0, 2, 0, then 2, 1, 1. You need to find the A inverse. So first equation is adjoint of A by determinant of A. Now let's find what is determinant of A. So determinant of A is 2 into 2 minus 0, minus of minus 1 into, then it is 0 minus 0, then plus 3, it is 0 minus 4. So it is equal to 2 into 2 is 4. That is equal to 4 plus 1 into 0 plus no, not plus, minus 12. Minus 12. So we'll get the answer minus 8. Okay, so determinant of A is equal to minus 8. Now you need to find the cofactors. Find all the cofactors. So it will be 0, and the other one is 2, 1, 1. Let's find the cofactor. So cofactor of A11 is equal to minus 1 raised to 1 plus 1, it is 2. Then it is 2 minus 0, that is 2 itself. Then A21 is equal to minus 1 raised to cube. So cover this particular column and the row, we will get it as 0. It will be 0 here. Then this is A12. A12 is equal to, this is A13. That is minus 1 raised to 4. Then you cover this particular column and the row, it will be 0 minus 4, we will get it as minus 4. Now A21 is equal to minus 1 raised to cube. You cover this particular column and the row. So we will get the answer as minus 1 minus 3. It is minus of minus 4. Now A22 is equal to minus 1 raised to 4, and it will be 2 into 1. Cover this column and this particular row, it is 2 into minus 2 minus 6 equals minus 4. Then A23 is equal to A23 is equal to, you cover this particular column and the row, so it will be 2 minus 1 raised to 5, minus 1 raised to 5, then cover this one, it will be 2 minus 2, 2 minus of minus 2, it will be 4, minus 4. Okay, now A31 is equal to minus 1 raised to 4. Then you cover this particular column and the row. You get the answer as 0 minus 6, that is minus 6. Then A32 is equal to minus 1 raised to 5. Then cover this column. It will be 0 minus 0. It will be 0. Then A33 is equal to minus 1 raised to 6. Then you cover this particular column and the row. It will be 4. Okay, so we read a cofactor, write all the cofactors now. 2, 0, minus 4, 4, minus 4, minus 4, then minus 6, 0, 4. These are the cofactors. Now, we need to find the transpose of this one. So, that will give you the adjoint of A. So, adjoint of A is equal to, we convert the row into column. So, 2, 0, minus 4, 4, minus 4, minus 4. Then we have minus 6, 0, 4. Now, A inverse will be equal to adjoint of A by determinant of A. So that is 1 by minus 8 into 2, 4, minus 6, 0, minus 4, 0, minus 4, minus 4, 4. So this is how we find I inverse. Hope this is clear for you. So in this lecture we learned how do we find the adjoint of a matrix. So adjoint of a matrix is defined as the transpose of the cofactor of that particular matrix, and inverse is calculated by adjoint of a matrix divided by determinant of that particular matrix. Thank you.